Okay, hello class. In this video, I am going to discuss to you the Hooke's law, axial deformation. But before that, let me discuss to you first what is strain. So from the previous learning material that I have sent to you, the mechanical properties of materials, and then yung discussion about strain. So previous chapter is all about stress. So now let's proceed with the strain. No? Okay, ang strain class is the unit deformation. It is denoted by a Greek letter epsilon. So that is the strain. Okay, so strain is also called as the unit deformation. So when you say deformation class, so it is the change in size, shape. So in this video or in this topic, which is axial deformation, we are referring to the axial deformation. So meaning change in length. Okay. So strain is from the word unit deformation. So meaning when a body is subjected to a force, specifically tensile force, nagkakaroon siya ng change in length. So, for example, a very simple example is a rubber band. So, kapag in-stretch mo yung rubber band, so meron kang ina-apply na tensile force. Ano? Okay, the tensile force, yun yung reason kung bakit nagkakaroon ng deformation. Na? Okay, so, simply, the strain is equivalent to the total deformation divided by the original length of the material. No? So, let's say, for example, you have 10 meters. So, let's say, meron kang 10 meters length na rod. And then, it is subjected to a tensile force. No? So, meron kang force P applied. So, equal. So, in-stretch mo or pinag-pull mo yung rod. No? So, let's say the length is 10 meters. No? So, meron kang original length is 10 meters. So, syempre, once tensile force is applied, so magkakaroon niya ng change in length. Ano? Okay, so yung change in length na yon, so which is the delta or the change in length. No? So, therefore, the strain now will be equal to so, let's say this is equivalent to 5 centimeter. So, let's say, nag-deform siya ng 5 centimeter from its original length na 10 meters. Na? So, the total deformation is 5 cm divided by its original length, which is 10 meters. So, what is now the strain? Na? So, therefore, ibig sabihin, 5 centimeter ang change in length per 10 meter. So, kung titingnan nyo, kung hindi ka mag-change muna ng unit, although strain is unitless, you will have 1 centimeter per 2 meter. Diba? So, 1 centimeter kada 2 metro. Kaso, epsilon is unit deformation. Unit deformation. Parang ang konsepto niyan is for every unit length, what is the elongation or contraction, deformation, na? So, ang applied force kasi might be a pull or push. So, when it is a pull, so tensile force, mag-cause siya ng lengthening, na? Change in length, hahaba siya, na? While, kapag compression naman yung applied force, magko-contract siya. So, therefore, magkakaroon ng shortening. Pero the idea is the same. So, the strain is the total deformation. Either it is a shortening or lengthening divided by the original length. So, in this case, 5 centimeter over 10 meters, dimensionless class ang strain. So, you can convert the denominator, change to centimeter, or the numerator, convert to meters, diba? So we have 1 cm over 200 centimeter. So 1 divided by 200 is equivalent to 0.005. 0.005. So this is now the strain. No? So unit deformation. Now, let us see the relationship of stress and strain. From the video dun sa in-upload ko sa LMS, which is the virtual laboratory for the tensile test of steel. Steel is ductile and it is subjected to a tensile force. So, ginamitan siya ng universal testing machine based doon sa in-upload ko na video. Now, the UTM, may grip sa taas, no? May grip yan sa taas. Meron din sa baba yung machine. Then, i-insert mo dyan ngayon yung steel or any metal na subject mo sa tensile test. So, tataas yan, the upper portion of the machine, tataas, and then may simulated yon. So, yung reading, so, yung computer application na din, yung stress-strain diagram, makikita mo, magpa-plot siya automatically. So, makikita nyo yun dun sa in-upload ko ng video. Okay, let us plot the stress-strain diagram. No? So, let's say, dito na lang. So, ito yung ordinate and abscissa. So, this represents the stress and this one for strain. So, kapag glass and steel, sinubject mo sa tensile test. So, from here, okay, proportional siya. May time na proportional yung stress sa strain. And that limit is until lang sa proportional limit. No? So, hanggang dito sa proportional limit, ang strength ng material class, ito yon, no? So, ito yung ginagamit natin sa strength of material, kung ano yung stress at this point, no? So, that is the yung ginagamit natin as strength of the material. Kasi, dito class, kapag na-reach niya tong stress na to dito sa point na ito, habang sinasubject to sa tensile, no? Kapag subjected yan sa tensile test, so meaning, nag-plot din yan dito simultaneously. Marireach niya yung proportional limit kapag nirelease mo yung force, no? Kapag nirelease mo yung force dun sa steel, kapag na-reach niya itong proportional limit, although nagkaroon na siya ng deformation, so babalik pa rin siya sa original shape. Unlike kapag naglampas na siya dyan, na-reach niya yung elastic limit, tapos medyo pa-curve na dyan yung, magiging pa-curve na yung iyong diagram. So, dito lang sa portion na ito, projected, makikita mo, almost linear siya. Na? Almost linear siya. So, that's why, hanggang dito sa point na ito, sa proportional limit, proportional yung stress sa strain. So, kasi kapag nag-exceed yan dyan, okay, habang nag-undergo yung tensile test, hanggang sa mag-fail yung bakal, no? Magkaka-rupture. Yung peak point, that is the ultimate stress or ultimate strength, no? So, dito lang tayo, no? Hanggang sa proportional limit. Kung makita mo, linear yan. So, from geometry, kapag line yan, so, makikita mo that the stress is directly proportional to the strain. Okay. So, we can now say that hanggang doon sa proportional limit, yun yung upper limit natin. Ano? So, the stress is proportional to the strain. Now, from algebra, that is equivalent to, stress is equivalent to K, ito yung proportionality constant natin, times epsilon. So, and this proportionality constant is what we call the modulus of elasticity. No? So that is the modulus of elasticity. We can replace K. That proportionality constant is the modulus of elasticity multiplied by the epsilon. Now, let us replace this strain by deformation, total deformation divided by the original length. So, kasi diniderive natin ngayon class yung um, equation ng total deformation. So, that is equivalent to sigma L divided by E. Sigma is the stress hanggang dun sa upper limit. Na? Okay, and then L is the original length, E is the modulus of elasticity. So, we can use this equation to determine the total elongation or contraction, yung shortening or lengthening. Okay, that is the total deformation. Positive sign kapag tensile, negative kapag compression. If the force or the stress is, if you have tensile stress, positive yon. So, ibig sabihin, nagkakaroon ng additional or humahaba yung original length from the original length. Kapag naman negative, pinupush mo. So, meaning to say, magkakaroon ng shortening. Okay, from the stress, so it's kapag sinabi kasi nating axial loading, it's either compressive or tensile, di ba? So, we can replace sigma by P over A. P over A multiplied by L over E. So, ibig sabihin, yung total deformation natin can also be expressed as PL over AE. P class is the axial load. Okay, when you say axial, it's either compressive or tensile. L is the original length. A is the cross-sectional area of the body. Take note that this area is the area perpendicular to the direction of the applied force. That's why axial na. So, E is the modulus of elasticity. E is a property of a material. So, usually, for steel, E is equivalent to 200 gigapascal. Or in English unit, that is equivalent to 29 times 10 raised to 6 PSI or pound per square inch. So, yan class. Ano? So, then P is either the push or pull or tensile or compressive force applied to the body. Then, magkakaroon siya ng deformation, change in length. So, this is the delta. No? Okay? So, another thing that you need to take note is that this equation is only applicable for a homogeneous material. So, meaning to say, kung steel lang, no? So, sometimes kasi, the material can be, so for a certain oblong made of steel, tapos another material na yung karugtong niya. So, this is applicable only class for a homogeneous material. No? Okay. And also, so these are the reminders for the use of this equation. Okay. So, the Greek letter delta is the total deformation, either either lengthening or shortening. Depende kung ang force P is compressive or tensile. So, the load must be axial. Then, the bar must have a constant cross-section and be homogeneous. So, ibig sabihin, halimbawa, yung rod, if you are dealing with a rod, yung deformation ng rod, make sure that the rod, its cross-sectional area is uniform na throughout the length. So, walang lumalaki, walang lumaliit doon sa cross-sectional area. E is constant, that is the modulus of elasticity. So, yun yung mga reminder sa use nitong equation na ito. Anyways, how about if the cross-sectional area is hindi uniform? Na? So, paliit or palaki ang cross-sectional area. So, you can use or you can express the equation as deformation is equivalent to the integral of the axial force x from the from one endpoint multiplied by L over A as a function of x, the cross-sectional area as a function of x kasi nga hindi uniform yung cross-sectional area. Kasi diba kung circular na let's say 0.4 square inch ang ang cross-sectional area, 0.4 throughout the length. But if not, you can express area as a function of x multiplied by E. E is constant, so kung ano yung material, yun na talaga yung E niya because E is a property. Still, iba ang E. Aluminum, if it is an aluminum, iba rin ang modulus of elasticity nun. So, it's a property of the material na ginamit doon sa structure. Okay? So, we have two equations here. This one and also this one. So, this is the simplified one kapag uniform ang cross-sectional area. Okay? Then, this one naman, you can use this equation, magko-consider ka ng element. Then, isa-summation mo lang yun, that's why integral, kasi ang integral is summation, diba? So, isa-sum up mo lang yung kinonsider mong element, so makukuha mo na yung total deformation, even if the cross-sectional area is not uniform. So, in the next video, I am going to give you an example to illustrate or to demonstrate the use of this equation. No? Okay.